Welcome to Lawrence High. This is a 10th grade Algebra 2 class taught by Mick Seaton.
Can I try to show you know what I mean?
Yeah. What's happened? Oh, because you spent all of your notes doing your quizzes and not.
Yeah, look.
Oh, you wrote the vertex here.
The vertex is on the max, so I still don't understand.
So it's just
A vertex is either a max when the
So we don't do the
graph
y.
or a min
When the graph
when the graph opens up. Okay, I think this was supposed to say when the graph opens down.
Vertex is the point. And when it's
Yeah.
when it's like filling down, it's how much. Yes. When it's selling.
So when it says the minimum value, it means just the y value.
When it's pointing up, it's max. When it's pointing down.
Yes. Yes. So you wrote maximum value. This goes up forever and ever and ever. So you want to write minimum value.
Is that down here?
So if it's a smile, it has a minimum. If it has a frown, it has a max.
Yes.
You do 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 do. How's it coming so far? Looking back at your notes. That's what I like to see. Yeah. So in this case, does it touch the y-axis or the x-axis? So then, none. None. Yeah, Miliana, you missed all of this yesterday, last class.
But didn't you foreshadow this before?
Probably.
It looks so familiar.
Maybe. I don't know if I was talking about this stuff specifically. Ooh, you know what we did? We talked about the number of real solutions before.
Yeah.
Yeah. Just answer what you can, and then when we go over it, you'll get it all.
Okay, what's a vertex?
It's the bottom of the, it's like the lowest point. Yeah, Feta, what's up? I would love to. It's the point. The vertex is the lowest point. So like look at the, Andrew. Like right here. What's that point? It's not 10. So look over. Goes over 1, 2, 3, and then upward. See right here? 1, 2, 3, upward. Yeah, you'd either want to write it like b equals that, or you want to write 0 comma that. Like either like this, b equals 7, or 0 comma 7.
And how do we find the?
So you said that there are no real solutions, which means there's not going to be any zeros. There's no x-intercepts.
So I just put a 0.
So 0 means like 0 is the answer.
Yeah.
So you can draw a little like that. That means no solution.
Okay.
It's our fancy math way. Thanks.
No, it's insects.
Just draw
None.
write a 0.
Okay, Rami.
No number. How do I know if it's
Correct.
max or min?
So is it the lowest point or the highest point?
The lowest point.
Then it's the min. There you go.
So
Missing Carla.
H.
Sadie's I already saw. So you just have to worry about this. Your minimum, you wrote as the whole point. You want to just put it as the y. Remember we wrote that in our notes last?
These are my notes.
It says the minimum is the y value of the vertex. So just the y. Yep. So does it cross the x-axis?
No.
Then none.
Wait, is it the number of I mean, is it the y-intercept? This is the y-intercept x never touches 0?
No, sorry, no x-intercept. It does touch the y-axis. The y-axis is this one.
X-intercept, but there's no y.
Other way. The y-intercept is this one. X-intercept is this way. So there are no x-intercepts, but it does touch the y-axis right up here.
So when it's 0, that was 0 and 3.
You want to
That
swap
would be the
these?
y-intercept.
Boop, boop, beep. You go left and right first, and then up and down. So 3, 1, not 1, 3.
Wait, why?
That's the way we always do points, coordinates. You always do x value first. If you think about it as like x comes before y.
Oh, yeah.
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 Good afternoon. Is where they touch the x or the y-axis. So x-intercepts, x-axis is the bottom one, y-intercept is the vertical. So it does touch the y-axis at that one point. So what coordinate point is that? Is what you'd put for your y-intercept. And then there's no x-intercepts.
So
Yeah.
the y-intercept is 7?
Thank you. Yeah. So,
Wait, wait.
yeah, the passage right there.
It didn't touch the x-axis, so there's no number nor zero.
Correctamundo. Okay, Maddie, we do not have still. Aliana, we don't have still.
How do I know if there's solution?
She's out today? If they touch the x-axis.
So there's no solution.
Correct. No, there's no real solutions, but we learned about imaginary solutions, remember? Yeah.
But it says number of real solutions.
So you would just say none, yeah. All right, guys, so last class we started going over stuff about quadratics. If you remember, I know a couple of you weren't here. Basically, we said we finished the stuff about imaginary numbers that you needed to know for now. You're going to learn more about imaginary numbers in pre-calc and calculus, but all you need to know as a 10th grader you have learned. So instead of starting your new chapter right before break, we said we'll hit some of the stuff that we didn't do well on in the diagnostic. Remember we did a diagnostic a couple classes ago? So we said, okay, we'll hit some of that stuff. Last class we did some stuff about quadratics. Today we're doing some systems of equations stuff, which you guys sort of seemed okay with when we talked about it, but for the most part, there was some confusion. All right, so that's what, if you're trying to write in your notes what the topic is, it's up there, systems of equations. All right, so I need my vertex. Yeah, what do you got, Miliana?
3 and 1.
3, 1. So I'd write it as a coordinate, 3, 1. Boop, boop. And it is right here on the graph. Beautiful. All right, the minimum or the maximum value. So does this have a minimum or a maximum? It has a minimum. It had a maximum, it would look like this. And the maximum would be up there. This is a minimum. All right, what's the minimum value, madam?
1.
Yep, and then I would say, I could either just say like 1, I could say like y equals 1, something like that. That's my minimum. Either way is fine. All right, the axis of symmetry. Can someone tell me what an axis of symmetry is, or at least tell the couple people who were not here? Yeah.
All I know is that symmetry means similar on both sides.
It does mean similar on both sides.
So usually it's the middle.
It is usually in the middle.
And what is that? It's the axis. The axis.
In this case, is it going to be a horizontal line or a vertical line?
Vertical line.
Vertical line. Ooh, I actually think I have a tool for that. Boo-doo-doo. Yeah, I do. I can make it an arrow, too. But it's white. Make it red. All right, so I'm drawing a vertical line that goes through the middle, like you guys said. What is the equation of that vertical line going to be?
5.
The number is 3. What letter goes in front?
X.
X equals 3. Bum, bum, bum.
Why does it? Oh, because that's where the point is.
Yep, so the axis of symmetry always goes through the vertex. This is my vertex right here. And the point is 3, 1. So you just say x equals 3. If it was a horizontal line, I would say y equals and then the thing. All right? If this is a vertical line, that's x equals. All right, number of real solutions. We do what? What do you mean opposite?
So like if it was vertical, usually theoretically it would be the x-axis.
Yeah. Okay, I see what you mean.
Make it the y-axis.
So like this line right here.
Even though it's y, it would be considered x.
Yeah. So, and the reason why is because like if I name points on this line, this point is 1, 6. This point is 7, 6. In both cases, the y is 6. So you'd say the equation is y equals 6.
And that's the same thing with the 3. It's always 3, 1, 3, 2.
Yep. Beautiful.
We're gonna work with graph that instead of going like up and down, they go to the side.
Probably not this year. That would probably be something that's more. That's probably next year. I mean, we might, because we might do a little bit of like exploration with Desmos, but probably not. We're not gonna like do the equations of them. Probably not. Fed, are we gonna answer the next question? All right. How many real solutions do we have? There's no real solutions, but we do have 2 imaginary solutions. And why do we know? Yeah, it does not cross the x-axis. So since it does not cross the x-axis, we have no solutions. What's my y-intercepts? So
0,
yeah, you can either say it one of 2 ways. Usually we use the letter b because then y equals mx plus b. We say b equals 7. Like the y-intercept is 7. It's this point right here. Or we can say the actual coordinate, which is 0, 7. All right, and the last one, zeros or x-intercepts.
None.
9. I told Anthony how you can write none. How do you write none?
Zero with the line up.
Yeah, so a lot of people want to put a 0 to say that there are none, but that technically means you're saying your solution is 0. So you have to put a little line through it like this, boop, to mean 0, 0. Hold on, let me think about it. I don't know, I feel like you could. I think typically people write it like this, but that might be a right-handed thing, I don't know.
Where did you see the imaginary numbers?
So there's 2 imaginary, it's just assumed. If there's no real solutions, that there's 2 imaginary solutions. Yeah. All right, any questions other than those ones that you gave me so far? You think you could do any of these things on the quizzes?
Yeah.
Here is our plan for today. We are going to learn about graphing systems of equations with graphing and substitution. If you want to do elimination, you can, but those aren't the 2 specifically that we are learning. And practicing using academic language to reach a consensus. So basically, you're going to be working with a partner. You're going to have the same problem, but you're going to try 2 different methods to solve it, and then see if you get it right. And then if you don't, talk about what happened so that you got it wrong, so that you can come up with a solution together. So yeah, Sylvia, you might want to go sit with Adam so you can be partners.
Come on.
All right, so the next thing we have to do, though, is our quizzes.
So the x substitution is on the x.
It's on the x.
So it will be x negative.
X equals, and then you look at what the x is. Yeah. Do you have your notes? Then maybe you can just take a picture.
I wrote them right here. Like I just wrote the definition.
That's when the
One solution, maximum value.
the solutions.
She wrote the cut the graph in half, but she didn't write the thing. That's yours. Always a vertical line, x.
116.
That one has a maximum,
Yeah, we
right?
take a picture of this.
Yeah,
so
that
you
one's
just have it for
yeah, that
reference.
one's nice. Oh wait, I did take a picture of that.
You Snapchat me this?
116.
Because it's in my eyes.
Bro, I can't read, bro.
Gotta keep your math in my eyes.
Oh yeah.
It's always the x.
Which one?
It's always the x value, right?
For the minimum or maximum, it's always the y.
The y, yeah.
It says the Y.
Cool, close one. That's you sure you got it? Where is the axis of symmetry? So what do we think?
A parabola, the vertex.
Parabola.
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 The vertex. It's that. Yes, that's parabola.
Yeah, so for axis of symmetry, it's the x, and the x in this case is,
-3.
yeah.
I didn't give me that shit wrong.
What is a system of linear equations? So if you want to just take a picture and you don't want to write it down because you already feel like you know it, that's fine. It just says that a system of linear equations is a set of 2 or more linear equations that share the same variables. What is a linear equation? What does it look like?
Straight.
Straight. It looks like a
Straight line.
line. That's how it has the word line right in it. Look, linear line. All right, so if we're talking about a system of linear equations, we are talking about 2 or more lines. And the solution to the system of equations is the xy coordinate that satisfies both of them. When we're talking about equations, can anybody guess what satisfies means? Yeah,
For both.
completes. Yeah, completes, sure. It works for them. It works for them, it completes them, it makes them happy. In this case, 2, 2 is a solution. It satisfies these equations because when I plug in 2, 2, I get them equal on both sides, and same thing over here. All right, so the solution to a system of equations is just the points where they intersect. Yeah? It's the coordinate that makes both of them true. Happy with that? This part's familiar? Okay. We learned 3 ways in Algebra 1 how to solve a system of equations. Can anybody tell me any of the 3 ways?
Wait, how to
Rise
solve
over
what?
How to solve a system of equations.
Rise over roll.
That's slope,
Oh.
which is part of one of the ways. I'll give you a hint. One starts with a G,
The one that equals each other, you put x. Wait.
one starts with a G, one starts with an S, and one starts with an E.
Nothing is coming into my parent.
Ways to solve systems of equations.
Wait. What is?
I'll give you the second letter, that'll help.
Yeah, that's the least.
Okay, so they've got GR, SU, and EF.
Graph.
Graphing, yeah, that is one.
Graphing.
Close.
Subtracting.
What?
It is, I'll give you the letters that are there. Substitution. and
Hitman.
elimination. We got it. Okay, those are the 3 ways that we learned last year. So I have my first point is going to be here. I know that my slope, there's no number there, so it's a 1. And I know that it says positive, goes up like this. So I know that I'm going to go up. How do I go up? What do I do?
Go up 1 into the right 1.
Yeah, what do we call that? Oh, you said that earlier. Rise over run. Right? Slope is rise over run. I'll write that. There's a lot of reminder vocabulary involved in reviewing this stuff. All right, so I can go up 1 over 1, up 1 over 1, up 1 over 1. Why don't I draw some points on here? Up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to try to connect it with this tool and see if oh, that's actually pretty good. I didn't do too bad. You booing my line? Can I make it? Oh, nope, it's too late to make it. Okay, that looks fine. All right, so there's our first line, y equals x plus 6. The second line, I have y equals negative 2x minus 3. What's that going to look like? Yes, Miliana.
You have to start at negative 3.
Start at negative 3. Which negative 3?
Negative 3y.
The y-axis negative 3, which is down here. Let me use a different color. Oh, I already used red.
And then that is 2 over 1, which you can go down to and then to the down to and then to the right. But I like to go to the right to and down. That makes sense.
So if our slope here is negative 2, you're saying I should go...
You could rise. You would have to go down to and to the right once. But I like to go up to.
Oh,
rise
up to. I thought you said the other way, and I was like, you can't just switch directions.
I like to go up to the left one.
Up to the left one, which would be this way. But you can go either way, and that's a good strategy to know because when you're doing this on the MCAS and it's online, it's kind of a really annoying tool that they give you to do it, and sometimes it doesn't let you go in a certain way. So knowing that you can go down and to the right or up and to the left is a good idea to know. All right, so I'm going to connect these. I'm going to try to do my best. Oh no, it's terrible. Oh no, that's the worst. Oh my gosh.
You
Okay.
change the color before you do it.
Oh, change it to a different color. Blue.
Matches. Or-
Okay. Take 2. Okay, that one's pretty good.
He's decent.
Goes through the dots. And this is honestly, I'm making a joke about it, but that's a common problem that people have is when they draw their lines, they don't try to draw them very straight. And then they think, oh, they connect right here, but then they don't. It's just because your line was, well, like wibbly wobbly.
That used to be.
All right, what's my solution going to be?
Wherever I connect.
Wherever they intersect. Where do they intersect?
1, 2,
What's that point?
I think it's 4 and 3. But I can't really see it. The bunch of squares are messing with my vision.
Negative 3, 3? Ooh, I made my pen real thin.
I think it's 3, 3 indeed.
Yeah,
3,
3.
3? Positive 3? Positive 3?
Yeah.
Yeah. No.
No.
Negative
It's
3,
negative
positive
3.
3.
So we've got negative 3, positive 3. We can test this. How can I check if I have the right answer?
Plug it in.
Plug it in, plug it
X
in.
equals 7 plus 9.
Yeah, so I'm going to plug in my negative 3 as my x. I'm going to plug my positive 3 in as my y, and I'm going to see if this works. All right, so y equals, I know my y is 3. My x is negative 3 plus 6. What's negative 3 plus 6?
3.
3. So I got 3 equals 3. That one works. However, a system of equations has to work for both lines. So let's try with the other one. Y is still 3. Negative 2 times x is negative 3. Minus 3? That's a lot of 3's. 6 minus 3? 3 minus 3? 3 equals 3. It works! Alright, so the system of equations has to work for both lines, and in this case, we got it working for both lines. The red one and the blue one. Yep, the pass is right there. Alright. So I'm just going to review to make sure we're cool with these graphs. You start at this number. What do I call this number? My y-intercept. So I start with my y-intercept. Y-intercept means it is on the y-axis. So I start with my y-intercept. Then I use this, which is my slope. And my slope tells me how much I go up or down, my rise over my run. In this case, I had a positive slope, so Mr. Slope Man says it goes up like this. It goes up 1, over 1, up 1, over 1, up 1, over 1.
Is there a different way you can do that without using right over? Just loving
I mean, I guess you could pick like a random number. Like you could pick a random value for x and then find out what the y would be. Yeah, it seems like way more work.
When you were checking, like, your answers, did you have to switch from, like, the equation, right?
Yeah. I'm not going to make you check them like this on your assignment today, because on the assignment today, your check is going to be your partner. One of you is going to solve it with this, and one of you is going to solve it with substitution. And if you both get the same answer, then you're good. If you don't get the same answer, then you're going to swap papers and see what happens.
The substitution is the second part?
Yeah, none of this is substitution yet. Well, technically this is using substitution, but that's not the substitution method. Yeah? Yes, it is kind of warm. I can't open the shade. Because if I open the shade, it will affect the lights apparently. But I can open the window. The camera. He said we can't have the lights on. Or we have to have all these lights on, but had to have the shades pulled. Okay, I want to show you real quick another way. And honestly, I thought this was really hard when I was in high school. And then somebody showed me like this method to use, and I was like, this changed everything for me. Which is what to do if it comes up in standard form. So when I was younger, they told me if it shows up like this, if you've got your equations in standard form, then you have to turn them into y-intercept, like y equals mx plus b, and then plot them. And then somebody showed me this other way to do it, and it blew my mind. It's so much easier, and I'm going to show it you right now. You ready?
Yes.
It's amazing. You're going to be like, oh, that's so much easier.
Wait, what was the other one called?
It's putting in y-intercept. They're already in y-intercept form, like y equals mx plus b.
This is called graphing standard form.
Oh, I think I just said graphing. Solving with graphing. Okay. Ready? Okay. So, if I want to graph these two lines, and I don't want to have to try to rewrite them into y equals mx plus b form, what I can do is I can, basically, you find the x-intercept and the y-intercept, which sounds like it's going to be tricky, but all you have to do is, like, if I'm starting with this first equation, I've got 5x minus y equals negative 5. You sort of just say, okay, let's say that x is 0. If x is 0, what would y be? So I honestly, when I do it, cover it with my hands. I say, if x is 0, this is going to go away. I'd have negative y equals negative 5. So if negative y equals negative 5, what's y?
5.
Right? And I can write that over here. If I have negative y equals negative 5, that would be y equals 5. So when x is 0, y is 5. 0, 5 is one of the points on the line. 0, 1, 2, 3, 4, 5. So when you are working through this, if you and your partner get different answers, you want to talk about them, and you might say, I agree or disagree with your answer because this. Like if you got 5-2 and they got 7-6, you'd be like, I disagree, let's figure out what's wrong. I noticed that, or a better strategy would be. And then words you want to use like coefficient, variables, the operator, or you could say like the sign, the constant. If you're talking about the slope, you might want to say slope. Let me put slope up there because it's not up there yet. So this number is also the slope. And this is also the y-intercept. All right, guys, so you can get started on this. You're going to do one. Your partner's going to do the other. You're going to check your answers to see if they're the same. If they are, move on. If they're different, start talking. All right? Here, you just need to put an equal sign between them. And then you just solve. Solve for x.
Yeah, but this one isn't, so you're gonna do x plus 6 equals negative 2x minus 3. And then you're gonna subtract 6. I mean, you're gonna add 2x from each side. This one has y equals, so we just have to make them equal to each other. Oh, I didn't write that exactly. No, because Mix didn't put that as an example. So,
Let's go, guys. Horrible.
no, you're gonna add 2x. So it's x plus 2x, 3x.
see if you end up with the same.
You have any eraser? So it's 3x, and then plus 6. That stays the same because it doesn't have an x next to it. And then equals -3. And now you're gonna subtract 6 from each side, since it doesn't have an x, you know. Then it's gonna be 3x equals -9. What you do next? To get the x by itself.
X equals -3, so -3 plus 6.
Could be y equals -3 plus 6. 6. Oh, it would be
3.
Oh, it would be 3. So you did something wrong.
No, now we have to switch because we both got different answers. So now we switch papers.
No,
and
now we need to see what we.
look. If they match, move on. If not, trade papers and check your partner's work.
Okay, hold on. Let me fix this. I got 6.
You got 6 for x? Okay. So then you're going to plug into this one? And find out what y is.
So 6, so x plus 6 equals 3.
X. You said x is 6, right? Or you're saying y is 6. Okay, so if you're saying this is y, then you want to say y equals 6. So then I'm going to plug in that here. X plus 6 equals 9. So what's x going to be?
3.
Okay, so your answer is that x is 3 and y is 6. When Janelle finishes, you're going to compare and see if they got the same answer as you. So you're going to put your answer here, 3, 6. You want to move on to the next one until they get there? That's fine.
Can you help me in this one as well?
Okay, so if I cover x, y is 9. Okay, so it's our 9.
Oh, that was easy.
I just don't see where the intersect.
You're -3.
Like my line is different. Then I have to solve myself.
You have to do it like yours. So you do yours and then I do mine.
But on this one?
Yeah, you do that one. And then when you're done, you put your answer right there.
1, 2, 3, 4, 5, 6.
So -3 goes where? Here or here?
¿Qué tú estás haciendo?
-3. No,
-3.
no, because that would be a whole different thing. So it would be down here. So 1, 2, 3, right here.
And then 2 down and 2. 2 right.
I feel like I did that all wrong. Can I get a